So we have a circuit here. We turn the potentiometer anti-clockwise, the servo goes anti-clockwise. We turn the pot clockwise, the servo goes clockwise. Imagine that we made some mistake, and in fact we wanted the inverse operation. When we turn the pot, we want the servo to go clockwise. Maybe we've made a design mistake, maybe the design intention was not adequately captured, we didn't have good alignment on scope with our team. In any case, we've gone to the trouble of making this physical circuit. We've had it manufactured, we've assembled it, we've tested it. It works well enough, but we just need to change something about it. This is where we can do circuit bodging. It would be maybe foolish and unnecessary to redesign this circuit board with a minor change, send it off, wait 2 weeks, receive it, spend more time and parts making another circuit board that's slightly different. You really want to squeeze the value out of every prototype that you make, and that might include these minor adjustments that you need to make, like reversing the direction of travel of this servo. So in this video, we're going to bodge this circuit. We're going to cut traces, introduce new connections, and basically change the topology of the circuit to make it behave differently. This is just to get you thinking about some helpful tricks that you can use to really get the most out of your prototypes. This isn't going to be an exhaustive cover of all bodges that you can do. It's just really to get you thinking about the techniques. So we've got this potentiometer, and it's not being used as a voltage divider, rather it's being used as a variable resistor in this circuit. The pins being used are the center pin and the right-handmost pin. We can see those traces coming in from the top. So as we turn the potentiometer to the left, the resistance between these two pins is increasing, and the resistance between the center and the left pin is decreasing. If we want to reflect the behavior of the pot, we would need to cut this trace and pick up this node off the left-hand point of the potentiometer, which now creates a variable resistor where the resistance increases as we turn it clockwise. In the current configuration, it decreases. Now I'm tethered by a microphone, so I'm going to use only what's at hand. My power supply is turned off, and all I really have are these side cutters. So that'll have to do. I'm going to cut this trace, which will break the connection between R2 and this pin of the potentiometer, and then I'm going to route a bit of wire from this pin of the potentiometer to R2. Instead of using these two pins, I'm going to use these two pins. There's a couple of things I could do. I could use a sharp instrument to cut this trace, and I am really using what I have available at hand. I'm tethered by this microphone in place, so I'm doing this with the minimum tools that you would want to do this. But if I carefully walk that blade over that trace, I can dig down into the fiberglass, and I can see that there is no shiny metal now. I believe I've severed that trace completely. You'd probably want to do this with like a hobby knife or a razor blade. I can use the continuity function of my meter to check for R2. I can find the end of that trace that I've cut, but if I bring it to my potentiometer, I can't see that connection again. So it looks like that is a clean cut. It's always worth getting a really tight visual inspection on cuts to make sure there's no copper. A microscope is a great idea. I don't have one right now. I'm going to use this piece of wire. I'm going to use this piece of wire and strip one end off it to reveal the copper. I'm going to measure it out because I don't like trimming wires that are already soldered, if I can help it, because it can stress the wire quite a bit. So I'll just strip the other end. I'm going to add some solder to that pin that I want to pick up from. Just so there's abundant solder on that pin. That's called tinning the pin. And now I can introduce my wire onto that tinned pin. Make sure there's no bridges between these. Now I can bring my bodge wire over to where I need it to connect to R2. I might just feed it in and it'll kind of hold itself there. That's quite convenient. will allow me to make that solder joint. This is a pretty thick wire. If you need to do a lot of these bodges, you might want to consider using thin enameled copper wire that you can burn the enamel off, or wire wrapping wire, which is a special thin wire that is solid core as well. Okay, so we've reflected the way that the pot works. This is the moment of truth. I haven't tried this before. Let's see if our bodge works. And there we go. If I turn the potentiometer to the right, the servo goes to the left. If I turn this, if I turn the potentiometer to the left, the servo goes to the right. We have reflected the direction that the servo works by cutting one trace and making a single new connection. And this is a perfectly acceptable thing to do. It's still like a valid circuit. This wire flapping in the breeze might be a little bit problematic, so you might want to glue it down, but otherwise this is a functioning circuit and super good enough for a prototype. There are consumer devices out there that exist with these kind of bodges built into them. Now there's probably no way for me to give you an exhaustive survey of all the bodges that are available to you, but hopefully this gets you thinking about the kinds of tricks that you can use to change the way your circuit works or to fix a circuit that doesn't work at all. So if for some reason you do make a circuit and it isn't quite right, rather than go through that lengthy process of spinning another board, you may just need to change one or two little things. Best of luck.